Good evening, learners. Very good evening. I hope all of you are fine. My name is Vishwadeep, and I am here to teach you computer organization here. And today, in the fourth lecture, we are going to cover components of computer already done. In that, we are going to cover the micro operations. So yesterday I have given you the basic detail of micro operation little bit. I can revise it again for a certain extent so that you can understand what is a micro operation, and then we will go further with more detailed discussion about micro operation. Fine. So whoever are here, all the people whoever have joined me here, okay. So you just like the video. All the people who have joined here, all those people like the video and subscribe the channel, right? So like the video and subscribe the channel, and then we will go further about the topic discussion. All the people who are preparing for gate exam, for them I am having really one important point to discuss. Okay, so if you are listening this lecture either live, or maybe if you are discussing or learning this particular lecture, listening this lecture offline, I just want to tell you that there are lakhs of students every year. Lakhs of students they are preparing every year, right? Yes, lakhs of students preparing every year for the gate. So they fill the form but they don't care about that. But among those lakhs of students, only thousands or maybe some 20% students are actually preparing or going for actual preparation. I'm not saying that they are joining some classes or something, but yes, they are actually preparing for gate. Actual means they are actually working hard on their preparation, on their practice, on their understanding, concept building, and so on. Among those 20%, only 5 to 10% students are getting the desired rank. So if you really want to be among those top 20% or top 5%, then you need to put more and more efforts. Now those efforts can be in what terms? First thing, of course, learning the concepts. Second thing, understanding the concepts so that you can employ that those or you can implement those concepts for the problem solving. And the third thing is practice, right? So all these three things you need to work hard and hard and hard for every subject, not only mine, for every subject. If you are really interested to crack the gate exam for the highest level marks, right? So if you are among those 20% who are really preparing hard for your exam, then you must be in last 5% who can actually get the maximum rank. For that particular thing, you need to have little extra efforts from your own end. How you can do? You can talk to me regarding your preparation strategies. You can talk to me regarding your preparation strategies, but you need to work harder for your career. I'm telling you one more time. Maybe if I told you the same thing, that if you can put 10 minutes of your day, then you should put those 10 minutes in that particular thing which can return you lots of things for your career, for your future. If you are putting your efforts, your energy in something, you need to put that energy efforts in that thing which can return you lot. Like I did in my engineering, maximum time I have given for my gate preparation. Why? Just because I knew that my other thing cannot give me or cannot give me the returns, but my exam preparation, gate exam preparation could have given me a lot, and it has actually paid off a lot in terms of money, in terms of status, in terms of my college, masters, every single thing. It has paid off. So you think wisely, work harder for it, and go on. Fine. Okay. So if you are really interested in learning, please learn a lot. And based on that, you can get whatever you wanted to. Fine, let's have our discussion further. If you are really interested in learning in some organized and some structured way every single course for your gate preparation, then the best way you can do is join the Unacademy subscription. And how you can join? It's very simple. Just download the app, get subscription for Gate EAC. use this code VDEEP10 and you can get 10% discount for that. If you are getting discount, that's the other thing, but if you are using my code, then I will be giving you my personal mentorship for your preparation. I have a lot of experience in teaching and I am in the touch of GATE exams since GATE 2009. So I know in and out that what type of questions they may ask, what kind of preparation if you will do, then you can get success in GATE exam. So till now, if I am in the touch of GATE, yes, of course, my mentorship can help you in making your marks better and better. My name is Vishwadeep. I have given GATE exam multiple times. Among those, this is one of my rank, which was in my fourth year, and there are certain more all India GATE rank I am having in computer science, including 682 in just third year. And at that time, I was knowing that how to target my GATE exam. So I am telling you, if you are really interested in GATE exam and it's the best result, then you need to have really good understanding of the target exam, right? Okay, so these are the courses I am going to teach you guys. Computer organization, which I'm teaching you here. Apart from that, I take data structures also, and apart from that, I take coding interview problems also for you. So these are the courses I'm going to teach on an Academy Plus platform. If you want to join it using this code VD10. Anytime you can get even call from an Academy side also. So if they are asking that if you have any code, you need to tell them this so that you will be eligible for my own personal mentorship. Okay, let's go further. These are the benefits of Plus subscription. All of you are aware that what are the benefits of Plus subscription which you cannot get on YouTube classes. Again and again, so many students are asking me. Once again, I'm telling you that yes, I will cover all the syllabus of computer organization here, but there is no any limit that when I am going to finish, plus when our team is going to finish the entire syllabus of your GATE computer science. If you want to have risk less preparation, more organized way, then Plus subscription will be the best way. Our target here in the YouTube is to provide you guys the best quality product. The quality content will be same to same, but extra thing which are required for the best marks you will get here in the Unacademy Plus. So join it here without any doubt if you are really serious about your own career. Fine. Okay, so how to get the subscription? Go to Get EAC. This is your goal. Get subscription and pay for it. Whichever time you will choose, based on that your payment will be shown. If you use this code VDEEP10, your discount will be given 10%. Fine, there are multiple options of payment. You can explore those. There are two debit cards, yes, HDFC, and another one is the Bajaj card. These two cards are providing you the debit card EMI also, and that to no cost EMI. Means for EMI option also you don't have to pay extra amount. If suppose you are choosing this much 12-month subscription, after discount this much, then that much only you are going to pay after even choosing the EMI option. So you can go with this also, and then you can go for the subscription. Fine. So just subscribe this channel so that you will be getting all the news about the announcement and the classes and everything. घंटी बजा दो जल्दी से, so that you will be getting all the notifications. People who have joined late, just like this video so that this particular video will go to or will go for the reach of maximum students. Okay, so let's start today's session on the micro operation. Before I'll go with this kind of thing, yesterday I explained you what is a micro operation. Micro operation is nothing but it's a very tiny or very small operation. So I told you yesterday that CPU performs one operation in small steps, and one small step is known as one micro operation. So this was the basic definition understanding of micro operation. Let's try to understand what type of micro operations we can have in the CPU. Okay, so these are the type of micro operations you can have in the CPU: arithmetic micro operations, logic micro operations, and shift micro operations. We will quickly visit all type one by one. Arithmetic operations are these many: addition. How you can denote addition in the RTL language statement? Like this: R2 plus R3. This is addition of two values into other one. Subtraction, yes, of course, you know all these. Subtraction is like this. You can denote micro operation subtraction. Complement means like this, right? What does the complement mean? Complement means every bit of register R2 will be flipped. 1 ka 0, 0 ka 1. 2's complement is what? 2's complement is 1's complement plus 1, and copy back to R1. Like this you can denote. Addition with 2's complement means you are adding R2 and 2's complement of R3 and copying the result in R1. Now, if you know the basic number system, then taking the 2's complement means what? You need to give an answer here. If you are aware of the 2's complement, what is 2's complement of a number? Taking 2's complement of a number means equal to what? Negation of the number. Taking the what? Negation of the number. So what exactly you are doing is, if number is given 5, 2's complement will represent minus 5. If number is given 10, 2's complement of that will give you minus 10. So this gives you what? Minus of R3. So exactly this particular operation is denoting R1 is equal to R2 minus R3 ultimately. So ultimately this particular operation is performing what? This operation is performing what? It is performing the subtraction of R3 from R2. I hope you guys are clear about this. I hope you guys are clear about this. If you are clear about this, let's go for next one. What is increment? Increment is this: R1 is equal to R1 plus 1, and decrement is subtract minus 1, subtract 1 from R1. So R1 is equal to R1 minus 1. These are the basic micro operations, right? Okay, that's good. So many people know about this. Let's go for the next one. Type of micro operation in logic type. Logic type, these four micro operations you have. Logical and you can have means what? R1 is equal to R2 and R3. Like this you write logical and. If you have studied the predicate logics, in the predicate logic you use this particular type of symbol for and operation, conjunction, right? And similarly for or, what you will use? Disjunction, like this. And then for XOR you will use the same symbol as you use in your Boolean algebra, plus and a circle among the plus. And then XNOR, same as in Boolean algebra, R2 dot and a circle R3. I hope you all are aware about the AND or XOR XNOR truth table. You need to speak here. If you are listening me here, you need to type down in the chat box and you need to send a message that if you know about it or not. Right or wrong, you need to tell me that if you know about it or not, that all the truth tables, how AND works, how OR works, XOR works, and XNOR works, right? If you know about it, just let me know so that I can understand. Okay, let's go further. Let's go further and let's try to understand this logical, shift micro operations. What is the shift micro operation? Okay, so there are three types of shift micro operations we can have: logical shift, circular shift rotation, and arithmetic shift. Okay, so many people have given me the answer. Yes, they know about the basic truth tables. Fine, that's good. Let's go further. Let's go further. Let's go further. Okay, so let's try to understand these three types of shift micro operations one by one. Logical shift. Let's start with this logical shift. In the logical shift, you will be having two types. Yes, for everything you will be having two types. For these two also you'll be having two types. You know the names, yeah. You are intelligent enough. Left shift and right shift. Right? So let us assume you have a register which can contain 4-bit value. You have a register which can contain 4-bit value like this. 1011. Now you want to shift it logically left side, means every single bit will be shifted left side 1111 position. If this bit I'll have to shift left side, if this bit I'll have to shift left side, is there any left position left? No, nothing. So this particular bit will be discarded, gone out. Why? Just because there is no any left side bit or left side position here to keep it. This bit will go on to the corner, then this bit will come, then this bit will come. Now this corner bit position is free, so we will introduce a new bit. Always new bit is 0. You remember, every time if you introduce a new bit, that should be 0. So after the logical left shift, this particular register will contain the output what? 0110. Now, right, right shift. Let's go with the right shift. If I am having a register with value 1011, how will you shift it in the right side? It's the exact same thing. How? The rightmost bit will be discarded, then remaining bits will be shifted one position towards right, and then a 0 will be added here. So what will be the answer after right logical shift on this 1011? Answer will be 0101. That's very simple. Okay, so if logical shift is clear, remember that one bit will be discarded, another new bit will be added. That will always be 0, whether it is left shift or right shift. Let's go further. Let's go further. Second one is circular shift. Circular shift is known as rotation also. And it says like this, that if you are going with circular left shift, there are two types here also, left and right, right? Okay, so let's suppose you have a register here too with value 1011. If circularly you want to shift, then leftmost bit, this time we are not going to discard. This particular leftmost bit will be circularly shifted here in the rightmost position, and remaining bits will be shifted towards left. 0, 1 and 1. So after circular shift, what will be the answer? 1011 was the initial value. Now 0111 is the value in the register after circular shift. Suppose I am having right shift on this number 1011. Right shift circular 1. So what happens? Rightmost bit circularly shifted towards the leftmost corner here, and remaining bits will be shifted 101 in the right side 11 position. Right, so answer will be 1101 in the register after the shift. Fine, that's good. So many people are interacting. That is really awesome. Really awesome. That's really awesome. People who have joined little late in the class, just like this video, so that this video will reach to the maximum number of students who are not able to afford the paid classes. Hence, they can watch this. Just because if most like videos are we are having, then of course more people will be there, means more people will be able to search this particular video. And one more thing I wanted to tell you, since last 3 classes, if you are attending my classes here, then I want to tell you one thing, that every topper of this particular exam, gate exam, should be from our family. If you are my student, I am your teacher, we are a family, right? So every topper, first ranker should be from our family, second topper should be from our family. We need to have that much of strong content, that much of strong belief on ourselves, and that much strong understanding over the concept, command over the concept that every single topper should be coming from us only. So whoever listening here, or either offline or just now online, everybody remember this point, that every topper of the GATE exam this next year or maybe next to next year should be from our own family. Okay, so let's go further and let's try to understand the third type, arithmetic shift. So before we understand the arithmetic shift, we need to understand few things here. What we need to understand is, what we need to understand here is, look at this, arithmetic shift can be performed on the signed value only. So you remember these two, logical shift and circular shift, applied on the non-signed or unsigned value. Unsigned value means no any sign, no any sign plus minus. But this arithmetic shift is applied on the, applied on what? Applied on signed values or signed numbers. Now, there is a catch here. What is the catch? In the arithmetic shift, there is a constraint. There is a constraint, and the constraint is what? The constraint is if you are performing any shift, whether it is left shift or right shift, any shift you are performing on any number which is the signed number, then after the shift, the sign should remain same. Means if positive number you have taken, you have applied the arithmetic shift, whether it is left or right, the sign should be positive only, the number should be positive only after the shift. And if you have taken initial number as negative number, then after arithmetic shift, the solution, the answer should be negative value only. Remember this point. I am writing that particular point here, that in the arithmetic shift, what happens in the arithmetic shift, it is applied on the signed number, one thing, and the second thing, after the shift, sign of the number, sign of the number should remain same, should remain same. Means positive ka positive, negative ka negative. Fine, if you are fine with this particular thing, then let's go further and let's try to understand the next few more things, that how exactly this particular shift is performed. Okay, so let's go and let's try to understand left and right shift. So I'll be explaining you the right shift first. That is easy also and simple to understand. With one example only you can understand it. Look at this, 1011. If you are going to shift this number, first of all, you tell me this number is positive or negative. See, when I say, you tell me, if I give little bit time to you, you need to type down in the comment box that what exactly your answer is. Then only I can understand that you are learning. Then only this particular class will be benefited. That yes, we are having little bit, at least little bit interaction. So when I am asking this number is positive or negative, you need to give me the answers, positive or negative. This is negative number. How can I say that? Just because MSB bit is 1. You all are aware of at least basic number system to ki basic number system says if first bit is 1 means negative number, if this is 0 then positive number, so it is negative number. Yes, if it is the negative number, then after the shift also it should be negative number. So how to perform the shift operation? Very simple thing. Rightmost bit discarded, 1 here, 0 here, this one here. What I will do, I will maintain the sign bit as it is. This one bit I will copy on two positions, this next to MSB also, on the MSB also. To keep it on the MSB, what it will help me, it will help me to maintain the sign. As I told, sign should remain same, right? So मैंने ये किया, the same bit I have copied here also and same bit I have copied here also. After the right shift, arithmetic right shift, number should be 1 1 0 and 1. I guess that is super clear to everybody. I hope so. Then let's go for the left shift. For the left shift, I am writing the concept here. it is same as logical left shift. Logical left shift, but it is allowed by CPU. It is allowed by CPU only when sign is not going to change. Not going to change means the method to apply the logical left shift and arithmetic left shift are same to same, but in the arithmetic left shift one extra constraint is added by your CPU. And how the number is negative, see this one, yeah, this bit is 1 means it's a negative number. If this bit will be 0 which means positive number, it's a basic number system. Arithmetic left shift and logical left shift both are same to same thing. In the arithmetic shift left shift one extra constraint is added by your CPU, and that extra content or constraint is what? The constraint is CPU will check if I will apply the left shift. If it is going to change my sign of the number, then I will not allow it. If sign will not change, then only I will allow it. Both example I'll tell you. I will give you both example. You can understand both the things one by one. Let's say this example number one. Example number one, suppose you have a value 1101. Let's apply the logical shift, or let's apply arithmetic left shift. Arithmetic left shift is same as logical left shift. If we will apply arithmetic left shift on this one, this particular bit is discarded, this bit comes to the corner, leftmost corner, then 0, then 1, and then another 0 added. So after 1100, I am getting 1010. You tell me this number was what? Positive or negative? MSB bit is 1 means it was a negative number. After the shift, this number becomes what? Still negative. So this particular operation is allowed by your CPU or not? Tell me. My answer is allowed. Your answer should also be saying same, allowed, right? So if allowed, okay, no problem. If suppose I am having another example like this, example number 2, if your value is like this 1011, after the shift what value you will be getting? Let's see. After the shift this particular one will be discarded, this 0 comes to the leftmost corner, then 1, then 1, then 0. So let's tell me what is this particular number before the shift. This particular number was a negative number. Now this number becomes a positive number. कैसे बोल दिया? This was 1, so negative. This is 0 now, so positive. Will this particular operation allowed by your CPU? No, not at all allowed. Means what happens, you know what happens even before performing this operation, by checking this value only, CPU will say that नहीं, इस पे arithmetic shift नहीं हो सकता. On this value arithmetic left shift cannot be performed. If cannot be performed, then what exactly CPU will generate? CPU will give you an error, and that error name is arithmetic left shift overflow. So what happens? What happens when such kind of number is there on which arithmetic left shift cannot be allowed? That particular number will cause an error called as arithmetic left shift overflow. Yes. So if sign is changing, then we are not going to allow, my CPU is not going to allow the arithmetic left shift operation on that number. And how CPU will test it, that sign is going to change or not? You guys are very intelligent. You can predict it easily. Look at this. If MSB bit is 1, and this is also 1, means MSB bit and next to MSB bit, if these two bits are same to same, if these two bits are same to same, then sign is not going to change. Why? Just because the MSB bit is discarded, this next bit comes to the corner. Here look at this, these two bits are not same to same. What happens if the MSB bit is discarded? This comes onto the sign bit position, and hence what happens? This changes the sign, which means what CPU checks is very simple thing. CPU checks that if the MSB bit and next to MSB bit both are same to same or not. If same to same, allow; not same to same, then overflow. Okay, so I hope you guys will remember this particular concept, and let's go further with some more understanding by solving the questions. So this is the very first question. It's just a practice question I am throwing you here. The number of the question is 2 just because we have solved one particular question previously in the program counter concept. So consider the following program segment. I will solve this question. Don't worry about it. Don't try. Just understand that how exactly we are going to solve such questions. Next question you will definitely try. Here R1 and R2 are general purpose registers. So I have kept R1 register and R2 register. Now further assume that the content of memory location 2000 is 23. So in the memory there is an address 2000. On that address right now the content is copied is 23. Copied this one, so this is the memory. Now further all the numbers are in decimal, so every calculation I'll do in my decimal number system. After the execution of this program, the value in memory location 2000 is okay. Let us try. First of all, this particular thing says that value 5 is copied into register R1. So I will set R1 is equal to value 5 in decimal. Next, second one is saying what? You need to access the memory. You need to access the memory on address 2000. What is address 2000 memory location? Value 23. So this says you need to read value 23 and copy it into register R2. R2 will get value 23. Now R2 is equal to R2 minus R1. So what it says, R2 is equal to R2 minus R1. 23 minus 5 gives me value 18 in the register R2. Right? Okay, there is a small change here. Actually, that's a mistake here. It should be P R2, not R3. So it's R2. There is no any register R3 here. Right now what I'll have to do, value of R2 I'll have to move into the memory on location 2000. What is the value of R2 right now? 18. This I'll have to move to the memory on which location 2000. So location 2000 updated by current value of R2, which is 18, and stop. So what is the question? What is the value at memory location 2000 after running this program completely? Answer of this question will be 18. I hope you guys understood this. I hope you could understand this. So here is the another question, which is a gate question, and this particular question you also will try. I will also solve along with you. Just read this first. Good, good, good. So many people could have given the answer correctly. Nice. So consider the following program segment R1, R2, R3 are the general purpose register. This is kind of a program we are having here. Okay, so let's try to understand. This is another memory read from 3000 location into R1, memory R3 into R2, R2 minus R1 into R2, then R3 location copied into 2000, R3 equals to R3 plus 1, R1 equals to R1 minus 1. What is this now? What is this now? Branch on not 0. What is this now? Yesterday I explained you this that the status register contains the status flag, and based on that we check the condition. But it stores the status of what? You need to recall that what exactly status register stores. The status register stores the previous instructions ALU's results status. So if previous instruction is this one, this will be the last thing which will be performed in ALU, and its status will be stored in the status register. So this particular condition will be checking this particular status. This ALU's result status. So branch on not zero means I can directly understand that if this R1 minus 1 gives you not zero, then branch here on the loop, this particular. So jumping will happen only when R minus 1 will not be zero. If R minus 1 becomes zero, means you don't jump, this condition will be false. So that is the understanding here. Let's go further and let's try to read the question completely. Assume that the content of memory location 3000 is 10. So I'm writing all those things here only so that I can solve the question. Fine. So content of memory location 3000 should come here downside. Why? Just because I know in the question there are few more things are given which are coming above. So content of memory location 3000 is having value 10. Next, the content of register R3 is 2000. So three registers you are having, R1, R2 and R3. Okay, let me make it little further, R2 and R3. And register R3 contains what? 2000. So register R3 contains 2000. Further given that the content of each of the memory location from 2000 to 2010 is 100, means all the locations starting from 2000. Fine. So let's say this is my location 2000. This is containing value 100. Next 2001 having value 100. 2002 having value 100. 300, 400, 500, 600. Similarly, up to what? Up to 9 also 100. Okay, let me make this 3000 little more down. I can cover up here 3000 location containing value 10 and 2010 also having value 100. Further, the program is loaded from the memory location 1000, which means what? Which means what? I need to extend this further up, and what I'll have to do, all these instructions, all these instructions are stored in the memory from which location? From 1000 location. So I'm writing all the instructions of the program started from location 1000. Fine. Further, what is given? Assume that memory is word addressable. As of now, I am just ignoring this statement. Why? Just because not needed for current purpose. I'll explain you little later that what is word addressable memory. The number of memory references for accessing the data in executing the program completely is. So I'll have to access the memory only for data. Only for data means for this instruction access? No, only for these data. Only for these data, how many memory references are required. Now by looking at the program, you could see that there is a loop. From where? Loop instruction starts from here, and this is the condition. So jumping should be from here to here. These many instructions are in the loop. These many instructions are in the loop. I don't know as of now that how many times the loop runs. I don't know as of now that how many times the loop runs. So let's assume for the first question, for this one, okay, let's assume loop runs X times. Why? Just because every time when the loop is running, multiple instructions are executed, right? So my number of memory references can increase when I am running the loop, and within the loop if I am having the memory references. First of all, you tell me if this first instruction is a memory reference or not. Yes, just because memory is referred. So this is memory reference. Second instruction is memory reference. Yes. This one is memory reference. No, there is no any memory reference here. Third, no. Fourth, memory reference. Yes, yes, memory is referred for the right purpose. This, no memory reference, no memory reference, no memory reference, no memory reference. I am talking about data access only. For these three instructions only, there is a data access from memory. This one, and this one. Now you see there are two instructions within the loop. You can see this instruction in the loop, this instruction in the loop, and this is outside loop. I hope you all are aware of the basic programming. Basic programming says what? Basic programming says that if any instruction is outside the loop, it can execute only one time. Any instruction which is inside the loop, that will execute as many as times the loop runs. So if two instructions you have within the loop, then and one instruction is outside the loop and it runs only one time, then I can say total memory references for data access is equal to how much? 2x inside the loop plus 1. Now what is this x? X is the how many times the loop runs. Suppose loop runs 100 times, then 200 times the memory is referred for the data access. If loop runs 10 times, 20 times the memory is referred for the data access within the loop. Plus 1, why plus 1? Just because this one access is outside the loop, so for this one plus 1 I have written. Now if that is the case, then based on that only C or D can be the correct option. Why? Just because this value will give you an odd number. If you are good in the numbers, 2 plus 2 into x will give you even plus 1 odd number. Fine. If that is the case, let's go further and let's try to execute this program. By executing this program, we can understand that how many times the loop runs. First instruction. Memory, you read on 3000 address. Memory, I'm reading on 3000 address. Here 3000 address is having value 10. This copy into R1, so R1 gets value 10. Next instruction, MR3. R3 is 2000, so read the value on memory location 2000. What is the value on memory location 2000? 100. Copy this into register R2, so 100 will be copied in register R2. Next, R2 is equal to R2 minus 1. R2 minus R1. So, okay, sorry, there is a mistake here. It should be R2 plus R1, not R2 minus R1. It should be a plus here. R2 plus R1 means 100 plus 10, 110. So this becomes 110 R2. Then after that, this value of R2. Okay, so here is the wrong statement. This particular statement's meaning is this, that memory of R3 should be having the value of R2. This is the statement. Move R3 comma R2 is R2 value. R2 value means 110 copied into memory on location R3. Location R3 means location 2000. On location 2000, copy the value of R2 which is 110. So previously it was 100. Now it has become 110. Further, next is what? R3 is equal to R3 plus 1. So R3 becomes R3 plus 1, 2001. This R1 equals to R1 minus 1. This becomes 9. Now, branch on not 0. Previous instructions result. This R1 minus 1 is 9, which is non-zero. Yes, non-zero. So jump means come here. Come here and execute this instruction again. Let's run this particular instruction again. Access the memory on R3 address. Now R3 address is 2001. 2001 value is 100. Copy into R2. So R2 value becomes 100 again. Now R2 equals to R2 plus 1. It becomes 109. Then this instruction R2 value 109 copy into memory on location R3. Location R3 is 2001. So 2001 location value is changed by R2 value. R2 is 109. Fine. Gaganshri, here we need to calculate the references for memory. Here is the memory reference, here is the memory reference. This is no any memory reference for this one. This is just the register reference for data access. That's why I'm not considering this addition and subtraction and other thing in this particular 2x plus 1. Okay, so 109 I have copied by this one. Now R3 equals to R3 plus 1, which becomes what? 2002. R1 equals to R1 minus 1 becomes 8. Then if this 8 is not 0, yes, not 0, then go up and again come here. Now what is R3? R3 is 2002. Read the value at 2200, copy into R2. So now again reading the 100 from the memory into R2. Now R2 is equal to R2 plus R1. R2 becomes 108. Then the same value R2 108 copy in the memory on location 2002, location R3, location 2002. Then what happens here? 108. Okay, so after that R3 equals to R3 plus 1, it becomes 2003. The next one is R1 minus 1 becomes 7. Now you can see that I am writing or I am checking the condition on R1, that if R1 is not 0, go back up, right? Go back up when R1 is not 0. When R1 will become 0? When R1 will become 0 after 7 more times. Means total how many times the loop runs. If R1 is initialized with 10 and you will run for R1 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. For R1 equals to 0 loop will run? No. R1 equals to 0 loop will not run. What happens in that case? The thing is very simple. What happens in that case? The case is very simple, that the loop runs how many times? How many times? 10 times. So you can understand x is value equal to 10. If x is 10, then this particular value become 2 into 10 plus 1. Answer is 21 number of memory references are required. Answer is this one. If suppose 10 times the loop runs, then these 10 memory locations are updated. Now you tell me the answer. Starting from 2000, starting from 2000, from what value 10 values are covered, or for what addresses 10 values will be covered. So starting from 2000, 2001, 3, 2, 3, 4, 5, up to when? Up to what address the 10 values will be covered. 10 values will be covered. So this becomes 107. This becomes 106. This becomes 105. This becomes 104, and dash 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 9 will become 101. Why? 10 values are gone till here. 10 times 10 values are gone here. 10 values are gone. You can see starting from 0, how many addresses up to 10 values? Next, 2009 only. 0 to 2009 only. Means 10 values are updated. Yes. Did you update 2010? You did not update 2010. Next question is that only. I am again skipping this particular statement, not required for this particular question solution, that after the execution of this program, the content of memory location 2010 is change ही नहीं हुआ boss. Change ही नहीं हुआ. Answer क्या आएगा? Answer will be 100. It's not even changed. Why? Just because you are updating 10 values. 10 values are from address 2000 to 2009. 2010 is not changed at all, unchanged. Answer is 100. It is very simple answer we could give here. Fine, now let's go for the third question. This is very specific, very specific. This is very specific. I hope till now you could understand. If not, then you can revisit the video again to understand the same question once more. Practice question number 3, based on the same given detail. This time they have written that assume the memory is byte addressable, and here I'll have to explain you what is the memory word addressable and byte addressable. So don't worry, I will explain you here that what is memory word addressable and memory byte addressable. So there are two types of memory we can have. One is word addressable, one is byte addressable. With the name itself, actually, it is clear. With the name itself, it is clear. Suppose you have a memory like this, right? The word addressable memory says that on each address, you can keep one word. How much you can keep? One word. On another address, you can keep in the memory one complete word, and it goes on same to same. That is the word addressable memory. Every word has one address, or in the other terms, every address is capable to store one complete word. Now, size of word can be what? It can be anything: 2 byte, 4 byte, 8 byte, 64 byte. Depends how you are keeping the word size. Okay, let's take a very simple example. I'm just assuming word size is equal to 4 bytes. Then, how many bytes are stored on a single address in the memory? Complete 4 byte. And here also complete 4 byte. Every address will have 4 bytes. Can you uniquely have an address for each and every byte in this world? No. हर एक बाइट का कोई एड्रेस नहीं. All 4 bytes will be read written at same time. Means every byte uniquely cannot be accessed. Why? Just because you can keep an address for one word, or you can keep one word on each address. That is why here byte addressable memory says what? Byte addressable memory says you can keep one byte on each address. You can keep what? One byte on each address. Means if you are having an address, on that address how much content you can keep is only 1 byte. Similarly, on next address also you can keep only 1 byte. Next address you can keep 1 byte, and next address you can keep 1 byte, and next address you can keep 1 byte. So every address is capable to store only 1 byte. That's it. So if suppose in this byte addressable memory, I want to store one word of 4 bytes, then I will require 4 different addresses. 4 bytes, one word will be stored on 4 different addresses. Okay, let's take a simple example. I always do this particular thing, that I always explain every single thing with real life example. Suppose 4 friends, 4 boys going for a trip, and they are going to stay in a hotel in a specific place. So if they are taking only single room to stay, all 4 boys in a single room, they are staying, then for every boy only one room number will be assigned in which they are staying. For every person, every friend, there will be only one room number. Hence, this is that word addressable memory. So all 4 bytes are staying in the single address or under the single number. Now, if 4 boys are taking 4 different rooms, then every boy will have their own what? Its own address, its own hotel room number will be unique for each and every boy, right? This is that case. So 4 boys if are staying, then 4 different room numbers are assigned to those 4 boys, just because they are staying one in each room, right? So if you can understand this example, that is also fine. Let's go further and let's try to understand this question. Assume that the memory is byte addressable, right? So the same thing I explained just now, word addressable, byte addressable, and the word size is 32 bits. 32 bits means how many bytes? कितनी बाइट होती है 32 bit में? 1 byte is equal to 8 bits, and hence 32 bits means 4 bytes. 8 fours are 32. If an interrupt occurs during the execution of an instruction INC R3, what is INC R3? This one. So during execution of this instruction, an interrupt occurs. What happens? What return address is pushed onto the stack? So you need to understand this first, that whenever an interrupt occurs during any instruction execution, then CPU will have to finish the current instruction execution. CPU will have to finish the current instruction execution. And after that only CPU will go for interrupt service. CPU needs to finish the current instruction execution, and after that only CPU can go for next instructions service or interrupt service for interrupt service. But once the interrupt service is done and CPU is coming back to the previous program, how CPU can go for that previous program execution? Should it restart the program from starting or should it resume the program? Your answer definitely will be resume the program. Why? Just because we have already executed so many instructions. Why to execute again all those instructions? Of course. So we will go further only. But how we will go further? No? How CPU will track that how many number of instructions we have executed or till what time we have executed the instructions. So what CPU does? What CPU does, if suppose during this instructions execution interrupt occurs, then CPU does what? Next instructions address, this one. This instructions address CPU stores onto the stack. CPU stores onto the stack. And you know why? You know why? So that once the interrupt service is done and when CPU will come back, then CPU can use that address of this instruction and CPU can resume the instruction execution from this instruction. So if in this particular case somebody is asking me that INCR3 during this instruction execution interrupt occurs, then what return address is pushed onto the stack? Then this instruction's address pushed onto the stack. Okay, so what happens in that case? I'll have to draw the storage. I'll have to draw the storage here, that how these instructions are stored in the memory. Okay, so first of all, what is the starting address of instructions? Given that the program is loaded from 1000, which means first instruction will start from address 1000 in the memory. Okay, for the easy purpose, I'm just giving the numbers. Okay, so let me clear it out every single thing. Okay, and I'm giving the numbers to each and every instruction. This is my instruction number 1, 2, 3, 4, 5, 6, 7, and 8. These are 8 instructions. What is the size of first instruction? What is the size of first instruction given in the words? 2 words. 2 words means how many bytes? 2 words means how many bytes? If one word is 4 bytes, 2 words means how many bytes? 8 bytes, right? So first instruction will be stored, instruction number 1 will be stored on 8 bytes. You know why 8 bytes? Just because question said that byte addressable. So 8 bytes means 8 addresses. So up to 1007 this instruction number 1 will be stored. Instruction number 2 will be starting from 1008. Its size is what? Its size is 1. So up to 1011 it will be stored. Then instruction number 3 will start from 1012. Then instruction number 4 also will start from 1016, just because instruction 3 is of one word only, you can check it out. Then instruction number 5 will start from 1020. Why? Just because this also of one word only. Then instruction number 6 will start from 1024, just because 5 is also of one word. 6 also of one word, so instruction number 7 can start from 1028. But instruction 7, you can see here instruction 7 is of 2 words, so it will take 8 bytes. It will take 8 bytes. And instruction number 8, the last instruction, will start from 1036. 28 to 35, it will take 8 bytes, 8 addresses in the byte addressable memory. Now during this instruction 5, I guess, yes, INCR3 instruction 5. INCR3 is instruction 5. During this execution, the interrupt occurs. So I am writing here during an instruction, if interrupt occurs, okay, let me make it a little better. Interrupt occurs, then CPU executes current instruction completely, and next instructions address next instructions address is pushed onto the stack, pushed onto the stack as return address, so that of course I can resume this program, right? So if during this instruction interrupt occurs, next instruction is this one, its first address, this one will be pushed onto the stack. So answer will be what? 1020. So here is an exercise for all of you. The exercise is solve this particular question and get the answer if the memory is word addressable. If memory will be word addressable, what will be the answer? Here two options actually I have given same to same. Try and solve this. If memory is word addressable, what will be the answer for this question? One exercise, and another exercise is this question. This particular question you need to solve today at home only. Right? Okay, I can discuss the answer of this particular question in the next class, but this is you can take as homework. It's another gate question you can solve at home and you solve it. How will you get this PDF? You will have to drop me a message on this particular Telegram ID. You just drop me a message on this Telegram ID and I can give you the PDF of this particular lecture, which is this, along with my writings. Fine. All the people who are following me on the Unacademy, that's good. If you are not following me on Unacademy, follow me there so that I will plan some more practice questions over there for you all, which are going to be free. So all those lectures you can attend and you can get all the information regarding the question solution. Okay, so follow me over there on Unacademy so that you can get the notification about your classes. If you are interested in better preparation for your gate, then you can join Unacademy Plus. Already my course, this specific course is going on there with full-fledged detail. This particular 13 July started, 1 week only gone, so you have not lost lots of things. All recordings are there, you can listen, you can ask any doubt if you have any problem. VDeep10 is my code, use it and then get the subscription. You will get more and more better mentorship from uh, my own specific mentorship. You can get it. Ashish, what kind of question you have asked? I am not having any question as of now for you. What should I reply? So these are my contact details. Any problem you are facing regarding your preparation, any course preparation, anything, how you want to distribute your time, how to prepare, how to prepare the short notes, or any kind of problem you have, just drop me a message on any of these social media and I will be helping you regarding the same. Fine. Till then, you can go and you just enjoy. Okay, there is another class after this class on TOC at 8:30 p.m. on the same channel, so you can log on to the same channel and then you can get the answer for those kind of TOC's questions. Okay, Ashish, I don't know where your comment has gone. It's not there. Left arithmetic shift, anything was there? Okay, no problem, you just drop me a message here and we will talk. Fine. Okay, so keep learning people, happy learning, and any problem you just drop me a message here. Okay, goodbye.